Ever looked up and wondered, what are those white lines behind airplanes? Are they skywriting, pollution, or just part of the engine smoke? Those streaks are called contrails, short for condensation trails. Here's what's happening. Airplane engines burn fuel, producing water vapor and carbon dioxide as byproducts. At high altitudes, where it's super cold, often below -40 degrees Celsius, that hot water vapor instantly freezes into tiny ice crystals. Those ice crystals form a visible white cloud, just like your breath on a cold morning but on a giant scale. Sometimes contrails disappear fast, other times they linger and spread out. That depends on humidity and wind at that altitude. In fact, scientists even study contrails to understand climate effects. Fun fact: some spy planes like the SR-71 were designed to fly so high and hot, they rarely left contrails to avoid being tracked. Why do you start crying like you're in a sad movie? Just by cutting an onion. It's not drama, it's science. When you slice into an onion, you're breaking its cells open. Inside those cells are enzymes and sulfur compounds that mix together, something that never happens until you cut it. The result? A gas called syn-propanethyl S-oxide is released. Sounds like a villain name, right? The gas rises up and reaches your eyes. Your eyes react to it as an irritant, so your tear glands kick in trying to flush it out. Here's a tip: chill your onion in the fridge before cutting. Cold slows down the chemical reaction so fewer tear gases are released. And did you know? Scientists have even bred tearless onions, but honestly, where's the fun in that? Ever wonder why you stumble when the bus suddenly moves? It's not bad balance, it's physics. When the bus starts moving, your body wants to stay still, thanks to something called inertia. Your feet move with the bus, but the rest of your body? Not so fast. You appear to fall backward, but really the bus is rushing forward under you. Hold on tight, or Newton's first law might just make you the star of a physics lesson. #physics every day. Subscribe for more cool science. Ouch! Ever touched a door handle and felt that tiny electric zap? Let's talk about why that happens. As you walk around, especially on carpet, your body is secretly collecting electrons. It's called static electricity. Basically, your body becomes a walking battery. And metal, well, it's a great conductor. When you touch the door handle, boom! The excess charge jumps from you to the metal. That's the shock. That tiny zap is actually a mini lightning bolt, no joke. It's the same principle, just on a way smaller scale. And you're more likely to get shocked in dry weather because moisture usually helps disperse the charges. Ever done this as a kid? Same science. Static electricity makes your hair stand up because the charged strands repel each other. Pro tip: touch metal with your knuckle first. It's less sensitive than your fingertip, so if there's a zap, you'll barely feel it. So, next time you shock yourself, don't get mad, thanks science.
Have you ever stood close to a platform edge when a train speeds by and felt like you're being pulled toward it? It's not your imagination. There's real physics at play here. Today, let's uncover why fast-moving trains seem to pull us in. When a train rushes past at high speed, it displaces a lot of air. This sudden movement creates a low-pressure zone near the train because the air between you and the train is moving quickly. According to Bernoulli's principle, faster-moving air leads to lower pressure. So the pressure between you and the train drops, while the air pressure behind you remains higher. This imbalance pushes you toward the train, giving you that pulled-in feeling. Here's a quick example. Watch this piece of paper. Same idea. The faster air above reduces pressure and the higher pressure below pushes it up. This is why train stations always ask you to stand behind the yellow line. The pull isn't from magnetism or the train's motion alone, it's aerodynamic pressure change. So next time you're at the station and a train flies past, remember, it's science in action. Stay safe, stand back, and let the physics impress you from a distance.